And these series, we have one special type of series called alternative series, in which in a series un with both positive and negative terms appearing alternatively. That means that the series that we discussed till now doesn't contain any negative terms. Either it contains only positive terms or only negative terms. We don't have any called alternating signs. Now we are going to consider that alternating signs here, and we are going to judge about the convergence and divergence of those type of series. Alternating series means the series in which both positive and negative terms appearing alternatively. Those type of series are known as alternating series. Those type of series can be typically written as minus 1 power n into un, n term. Now, to test their convergence and divergence, we have one specific test known as Lipnitis test, in which an alternating series is convergent if and only if it follows these two conditions. Each term is numerically less than the previous term. That means un must be greater than un plus 1. If I have first term and second term, first term must be greater than second term. Second term must be greater than third term. Third term must be greater than fourth term. That means it must be in descending order. The values must be decreasing. And the second condition is when limit n tends to infinity, un must be 0. That means when n tends to infinity, the infinite term in this sequence must be 0. That's what we wrote here, right? If we start from 10,000 value, we have to get degrees. After infinite uh, steps, we have to get to 0. That's what it's saying. Yeah. And we are going to discuss about this absolute and conditional convergence. The series summation un with both positive and negative terms, not necessarily alternatively. It is called absolute convergent. The series called absolute convergent if corresponding series modulus of un with all positive terms is convergent. That means first we discussed about the series which contains only positive terms or only positive terms or only negative terms. Next, we discussed about alternating series in which we contain both positive and negative, but appearing alternatively. If first term is this thing, and we have to get the second thing as negative, and third thing has to be positive, fourth thing has to be negative. Like that, it must and should appear alternatively. But we are going to have certain type of series in which we are going to see a plus and minus signs, not necessarily in alternating conditions. To judge the convergence of those type of series, we have special methods known as absolute and conditional convergence. The series un with both positive and negative terms, not necessarily. That's what I mentioned, right? Not necessarily alternatively, is called absolutely convergent. Those type of series will be absolutely convergent when uh, the mod values of whole the mod values of whole series is convergent. We have just consider we have 1 comma 3 comma 8 comma minus 9 comma minus 11 comma minus 19 comma minus 31 comma minus 58 comma and so on. If you have this type of series, we want to judge the convergence or divergence of this series. If you are going to consider absolute values of this whole series, just like 1, 3, 8, 9, 11, 19, 31, 58, and so on, if these series are the series which containing all positive values, if it's going to be convergent and the original series is also convergent, then we are going to say it as an absolute converging series. Otherwise, if it is convergent, but the positive terms values is not convergent, then we are going to say that conditionally convergent. If and only if both series are convergent, then we are going to say it absolute convergent. If any one of the series is going to be divergent, then we are going to say it conditionally convergent. Just consider a example. Determine the absolute or conditional convergence of a series minus 1 power n square by n cube plus 1. This is what they have given. Yeah. First, we are taking the nth value minus 1 power n square by n cube plus 1. Therefore, we are considering only the positive values, I mean, absolute values of the whole series. We are considering n square by n cube plus 1. And what we call, as the whole series contains only positive terms, we are using comparison test to find its convergence and divergence. I said how to find the convergence and divergence of an un summation un by using summation vn. Same analogy will be going to use to test its convergence and divergence. Now, now to check the convergence of summation un, we spoke about Leibniz rule in a alternating series, right? We are going to use that analogy. First, we are going to check if what we call absolute value of preceding term is greater than or succeeding value or not. We are checking that n cube minus n square by n cube plus 1 minus n plus 1 whole square by n plus 1 whole cube. As here n cube is dominating, if if a small change in n cube causes significant change in whole value, as denominator is more dominating, if denominator increases, the whole term value get reduces. As n cube increasing, n plus 1 whole cube, this whole term will be less than this thing, right? It's a basic common sense. Then we can say that it's always greater than 0. This is always greater than 0. Then we can say that uh, n square by n cube plus 1 greater than n plus 1 whole square by n plus 1 whole cube plus 1. Yeah, we just showed reduce this condition. Now we are going to look at the second condition. Limit n tends to infinity. Nth value of an given series must and should tends to 0. Just take n square, n cube common in denominator. Then n square and n cube will get cancelled. We are remained with n in the denominator into 1 plus 1 by n cube. When limit n tends to infinity, this term is going to be 0. 1 by infinity, this is going to be 0. 1 by n into 1, it remains. As n value is infinity, it comes 1 by infinity. That equal 1 by infinity is 0. And we deduce that it satisfied both the conditions. By Leibniz rule, we can say that the summation un is convergent. By Leibniz rule, we can say that summation un is convergent. Here, modulus of un summation un is convergent, and normally also given is convergent. We can now we can judge that the given series is absolutely convergent. If anything got failed in any of this case, we are going to say it as conditionally convergent. This is a whole topic regarding uh, series, sequential series. If you have any doubt, please do ask in comments. Thank you. Meet you in next lecture.